What are the key features of quadratic functions? So a quadratic function is a function where you have like y or f of x equals some number, so a coefficient of a times x squared plus a coefficient of b times x plus c. Now, that's the general form we see it in. The highest exponent you're going to see is the square in the quadratic function, and it forms a graph called a parabola. P-A-R-A-B-O-L-A, parabola. That's an important term that you're going to hear a lot when we talk about quadratic functions. The graph is called a parabola. Now here's some other terms we're going to talk about. The vertex, which is usually the same as the minimum or the maximum, depending on if A is positive or negative. If the A is a positive value, your vertex is going to be a minimum. If A is a negative value, your vertex is a maximum. You'll see that in a second when I show you a graph of a parabola. Axis of symmetry, a parabola is a symmetrical figure, and so there's a x line, a vertical line that is called the axis of symmetry that you can fold it over on itself. The domain and range. Generally, your domain's always going to be all x values, but the range will be dependent upon the vertex if it's a minimum or maximum. Y-intercept is when you substitute in 0 for x. Where does it show up? And that's going to always be whatever your c value is, because if you put a 0 here and here, the a and the b become 0. So you just, whatever the c value is will be your y-intercept. It'll be 0, comma, c. And then your zeros. The zeros, because a function can't have two different values for the x. So zeros is when y is equal to 0. What is x equal? And there's going to be 2 locations for that in every quadratic function, or there will be no locations, or you could potentially have 1. There won't always be 2. So there could be 2, 1, or 0, but yeah, there will never be more than 2. All right, so here's this. This is a graph of a scuba diver, right? The scuba diver has an oxygen tank, and over time, minutes on our x-axis, they go diving, and they go down, right? And here's the function. d of x equals 4/10 x squared minus 8x. Note there's no plus or any constant over here. So there's no c value, which means that over here, our y-intercept is actually going to be 0, 0. When x is 0, y is 0. And so this origin is the y-intercept. Coincidentally, that's also where it crosses the x-axis. So that's where the y value is 0. So here's 1, 0. Here's another. This one has 2 zeros. You can see all the way down here on the bottom, since my a value is positive, my vertex is going to be here, and the parabola is this black line here, and it looks almost like a U. And that becomes a minimum. So my vertex is the minimum. That's actually at 10, comma, negative 40. And here, my domain is going to go on forever in both directions. So my domain in this case would be from negative infinity to positive infinity, or realistically, you could say from 0 to, in this case, I would say my domain, because the problem I took this from said the oxygen tank could only hold water, only enough oxygen for 25 minutes, which means your domain is going to be from 0 to 25, because you don't have enough time. After 25, you're out of oxygen, so the graph is kind of irrelevant. And at the same time, if you're talking about this problem, there was a thing that said that, Sally said that the diver didn't have enough oxygen to make the dive, and, Joe said that the diver did. Well, the diver does, because you can see up here the other 0 is at 20, and so 20 is less than 25 minutes, so there'd be enough oxygen here at the other 0 when the diver gets back to the surface, right? So our depth here is a depth of negative 30 at 5 minutes. And so anyways, let's talk about the range, and I'll talk about these 2 coordinates and coming up with an average rate of change, which is something you might also be asked to do. The range itself is going to be here from negative 40 and up to positive infinity. Although in this scuba diver situation, the range is really going to be from 0, it could be from negative 40 to 0, because it really ends once he gets back to the surface. The scuba diver doesn't get to the top of the water and then start flying, right? Okay, so now if it wants me to come up with my average rate of change, say from 5 minutes to 10 minutes, Well, at 5 minutes, we're negative 30 feet deep. So my x is 5 comma negative 30. And at 10 minutes, I'm negative 40 feet deep. So your change in y over change in x is how you figure out your rate of change. So my change in y is minus 10, and my change in x is 5. So my average rate of change from 5 to 10 minutes would be, negative 30 minus 40. Minus negative 4, yeah. So this would actually be positive. Negative 30, change in y, negative 30, makes me try to make a mistake here. Minus negative 40 is actually adding, so it'll be that. And then I do 5 minus 10, which would be negative. So it will be a negative 5. So 10/5 it ends up being negative 2. That's what I thought. That's what it should be. My average rate of change would be negative 2 from 5 to 10. That's not a straight line there because a parabola and a quadratic don't make a straight line. It's a curved line here. And it's perfectly symmetrical. Here's our axis of symmetry. I think I forgot to talk about that. Right here at x equals 10. This line is the symmetrical axis. You could fold it over, it would be symmetrical. So what are the key features of quadratic functions? We talked about the vertex axis of symmetry, domain, range, y-intercept, zeros, a parabola, also your average rate of change. So a lot of vocabulary to introduce here and get used to. We'll do some practice with it in class.